Hello, Coach Travis here with another calculus problem. So this is a problem about horizontal asymptotes. So we got a question here. Determine the horizontal asymptotes of this function. Okay, so here's the deal. Horizontal asymptotes it's about end behavior. And end behavior is what happens when x gets really, really big. And so that would be the limit as x goes to infinity. And what happens when x gets really, really negative. And so that would be the limit as x goes to negative infinity. So if you want to find the horizontal asymptotes of a function, these are the two limits you always have to look at. You look at the limit as x goes to positive infinity, and you look at the limit as x goes to negative infinity. And okay, well, so now that we've got that settled, how do you actually figure out what those limits are? And I think the easiest way to figure out what these limits are is just imagine what happens when you plug in a really, really big number. So like if I imagine x is 1 billion, then what's going to happen to this function? Well, let's look at it one piece at a time. If x is 1 billion, this is going to be 1 divided by 1 billion squared. And 1 billion squared is a really big number. And you should know that if I have 1 and I divide it by a really big number, that's going to be a really small number. That's going to be really close to 0. Because again, like if I have 1 cookie and I have to share it with 1 billion squared people, each person basically gets no cookie. And same deal over here. This one's even worse. I've got 1 cookie and I'm sharing it with 1 billion cubed people. Well, that's practically 0. And then the 5, well, 5 doesn't do anything. 5 doesn't care about x, so 5 is just going to be 5. So this limit is equal to 5. So all right, so we can conclude that we have a horizontal asymptote at x, sorry, not at x, at y. At y is equal to 5, so I want a horizontal line. So I'll write that down here. Horizontal asymptote at y is equal to 5. And then let's see here. Again, oh yeah, why the y equals? Because again, a horizontal asymptote is a horizontal line. And a horizontal line always has the equation like y equals something. And so in this case, it's 5. And okay, so now I have to do the whole thing again. But this time with a negative number. Like this time I try plugging in a negative billion. Well, if you think about it, it's going to be kind of the same thing, only this time it's going to be like -0. And this time this is going to be -0. But who cares? 0 is 0, right? Whether it's positive or negative. I guess you might say, is -0 a thing? Is it legal? Is it mathematically legal to write -0? And the answer is yeah. There's nothing wrong with writing -0. It just is a fact that -0 is equal to regular 0. I guess if you wanted to, you could write +0. Those are all the same. I mean, it's not wrong to write any of those things. They're just all the same thing. And so most of the time we just write plain 0. But the point being, if x goes to negative infinity, this guy is going to 0, this guy's going to 0. And once again, we get 5. So we already knew that was a horizontal asymptote. So it just turns out that we don't get any more information. So we have the moral is that we have 1 horizontal asymptote. And oh yeah, and that's a good point. Sometimes these might be different. Now, so don't take for granted that these are always the same. In a lot of examples, they will be the same, but there are functions out there where these will be different numbers. And if these are different numbers, then it just means you have 2 horizontal asymptotes. So it's possible for a function to look like, you know, your function could look like this, where, I mean, our function doesn't look like this. So just to be clear, this function does not look like this, but just theoretically, there are functions that look like this, and they have one that you get one number when you go to the right, and you get a different number when you go to the left. And so then in that case, these would be two different numbers. And that would just mean that you would have two horizontal asymptotes. But that didn't happen in our case. They're both the same number. So we just have one horizontal asymptote, and there it is.